So now that we've studied probability theory, now we're ready to start talking a little bit about statistics. So this is section 7.1, is visual representation of data. Now, probability and statistics are two very related fields. One could say that probability is the theoretical understanding of trying to understand chance. And statistics is knowing that you live in a world where chance is existing and you're seeing things and you're supposed to try to draw patterns out so you can figure out what laws of probabilities are at work below it, right? That's the difference between someone who says, okay, I've got a die and each side is equally likely to show up. That's probability theory. And then if someone takes a die and rolls it 1,000 times and records the outcomes and then tries to reason what laws govern the die rolling, that's more of a statistical understanding. Right? So in statistics, we don't necessarily know what the underlying probabilities going on are, but we're trying to identify some sort of trends that we might see. And so today, statistics can often be helpfully understood with charts. And of course, charts are sometimes hard to read, and sometimes tables are better. So we're just going to talk about some different ways of visually representing data. These things are probably all very familiar with you. Okay, so we're going to start with a table. Okay, let's say we poll college students and ask them what is the highest degree they plan to achieve. And we get numerical responses, right? So some say the highest degree they're going to achieve is a bachelor's, some a master's, some a PhD, maybe MDs, law degrees, JDs, strange other degrees, degrees in mystical arts or something, I don't know really. And these are the numbers we get. So 29,791 say they're going to stop with their bachelor's. 59,441 say they're going to stop with their master's. 26,000 fools say they will get a PhD. 15,000 say they're going to get their medical degree. 5,930 say they're going to get a law degree. And this basket of other degrees has 3,388 people in it, for a total of 141,189 students. That was the total that was polled. Okay. And looking at that data, I mean, right, that's the data. There's nothing, it's right there, it's staring at us, but our minds don't work very well with lists of numbers. Our minds work well, a little bit better with pictures, right? And so we may want to visualize the data. And usually what we have to do is we have to do some work, maybe first to visualize the data. Let's record the percentage of students that are in each of these classes. So in this column, I'm just going to be taking the number here and dividing it by the total number there. So we get 21.1%, 42.1%, 19%, 11.2%, 4.2%, 2.4%, and then of course 100%. All right, so if we wanted to make a bar chart with this data, we are ready to go. On the bar chart, we would have something like this. We have a frequency on the y-axis and the choice on the x-axis. So we'd have something like a BA category, MA category, PhD category, medical doctor category, doctor of jurisprudence category, and other. And then on this side, we can, depending on how we want to show our data, here could be the total number, or it could be the percentage. We could choose either of those two ways to present our data. right? I think maybe let's do percentage over here. So the top of ours, let's see, 10, 20, 30, 40. Let's make our, we have graph, I have graph paper here, so I may as well make this graph reasonably good here. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so here's my bar graph. 21% say they're going to get a BA, so right, we draw this bar at 21%. 42% say MA, so I go up to 42% thereabouts, draw a bar. 19% say PhD. 11% say MD. 4% say JD. And 2% say other. Okay, so there's my bar chart. This is straight. I don't know. This has got to be completely made up data. In what universe do more people say I'm going to get my PhD than become a medical doctor, right? Like, everyone says they're going to become a doctor, right? I mean, maybe not the business school students, but that's normally what I see, right? Everyone says I'm going to become a doctor. And then they take me for calculus, and then it's all over, right? The dream dies quickly. Okay, so there's a bar chart, right? That's a bar chart. That's just a way of looking at things. We've seen these before. Another chart that people like is the pie chart, right? I mean, first off, there's all these puns you can make. Whatever, pie charts, right? We know what a pie chart is. Question is, how do you draw a pie chart? The correct answer is, of course, you find a computer program that will draw it for you. But if you had to do it by hand, what you would do is to get the angle for the pie chart, you multiply the percentages by 360 degrees. Now you guys are all business school students, so you probably even like have classes where you make pie charts. Is that true? Does this happen? Yeah. So this is doubly insulting that we're doing this, right? Because you've already had this, and this is really, we're aware of such things. Right? Okay, so I could multiply all of those, percentages like that. So the 21.1%, I would multiply by 360 degrees, and I get a 76-degree slice of the pie chart. And then, of course, I would get my protractor out, and I would draw my 76-degree angle in the middle of the pie chart, right? Why would I do this, right? This is a job for a computer, obviously. Okay, but that's how you take a pie chart. Another type of chart you might see sometimes is something called a histogram. And a histogram displays occurrence of a phenomenon or event. So I'm going to write some data, and we'll draw a histogram for it. Let's say I wanted to look at the quiz scores of my students, and let's say the quiz has a possible of 10 points, so I want to look at how many students got each possible score. So those are all the possible scores, and here's the number of students. So this would be 2, 1, 0, 1, 1, 3, 2, 3, 4, 3, 5. Okay, so that's just the distribution of the student scores. And let's say, note that there's a total of 25 students total. So what the histogram is going to do is it's going to have the test scores at the bottom and the number of students as the vertical axis. So test score of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then number of students for 1, 2, 3, 4, and 5 is the most frequent number, so we'll only need those 5. And now we draw our picture. Here we go. Nothing at 2. Box of height 1 at 3 and at 4. 5 gets 3 students. 6 gets 2 students. 7 gets 3 students. 8 gets 4 students. 9 gets 3 students. And 10 gets 5 students. So there's our histogram, which plots the frequency of something. Okay. Now, oftentimes when we have a data set, there's special numbers we want to know about the data set, which I'm sure you're aware of. One of the most important ones is something called the median. Right? The median of a data set, okay, is as follows. When data is numerical, the median is the number separating the upper and lower halves of the data. So the median is the number that separates the upper half of the class from the lower half of the class in terms of these test scores. So in this instance, we have 25 students total. Odd numbers are great for finding medians because the 13th score will be the one that separates the bottom 12 from the upper 12 in the class. So the median here is going to be the 13th largest score. So I can count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 7 here is the median for this data set. 7 is the median. Now, another type of data point that is important, another statistic that's important from data, are the quartiles, the upper and lower quartiles. Okay? And here we have to be careful because there's different ways of defining quartiles, and the book defines it in a specific way. So Q1 is going to be the first quartile, and it is the median of the numbers less than the median. And quartile 3 is going to be the median of the numbers larger than the median. Now this statement is kind of misleading actually, because the way this is phrased here in the textbook, if we say the median of the numbers less than the median, we would discount those 2 7 scores that came before we got to the median, because the number 7 is the median. We don't want to do that, right? We don't want to discount those 7s. So and of course the median itself, we could think of it as instead of the median, we could think of it as Q2. The median is Q2. So the quartiles separate the various quarters of the data. A quarter of the data is less than Q1. A quarter of the data is between Q1 and Q2, also known as the median. A quarter of the data is between the median and the third quartile. And then a quarter of the data is larger than the third quartile. That's what we mean by these quartiles. And so let's calculate these quartiles for the data above. So there are 25 students, so there are 12 scores, or 12 students less than or equal to the median. Okay? These are these students here. Now, there's not a number in the middle of 12, right? Because 12 is an even number. So let's look here. We have 1, 2, 3, 4, 5, 6, 7. So the 6th student scored a 4. The 7th student scored a 5. So the question is, which of these two numbers should we take to be the quartile? Well, let's take the average of the two. So Q1 is going to be 4 plus 5 over 2, okay, which is 4.5. And we want a number that is in between the 6th and 7th best score. Because then 6 scores are lower than this number and 6 scores are higher than this number. That's what we're looking for. So that's why we chose 4.5. Okay, now for the third quartile, we have to look at these upper 12 students, which there's 5 here, 4 here, 3 here. Right? Those are the upper 12 students. And the median number of those upper 12 students is 3. So we have 9, excuse me. Okay, so we have 4 8s, 3 9s, and 10 or 5 10s. If we wrote those numbers out, right, we'd have 4 8s, 8, 8, 8, 8, 3 9s, 9, and 5 10s. The number in the middle, 1, 2, 3, 4, 5, 6, is these two 9s are in the middle. And since they're the same number, we don't have to take an average. We just say that it's 9. Now, there's a special type of plot that uses these medians and the quartiles called a box plot. And I'm going to draw a generic picture of a box plot. So we have data. And the y-axis doesn't actually mean anything for a box plot. So the box plot looks like this. And the left end of the box plot is the minimum number in the data set. And the right number over here is the maximum number. The number with this bar in the middle of the box is the median. This number, the right edge of the box, is Q3, and the left edge of the box is Q1. And this gives you a reasonably nice picture of the spread of the data in some sense. It lets you know how tightly the data is packed around the medians. It lets you know, yeah. It gives you a quick picture of it. So let's draw the box plot for the test scores that we had here. So let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the median we already calculated, right? The median was 7. So there's a line there. The Q3 was 9. And Q1 was 4.5, so we want between 4 and 5. And we draw the box like this. The maximum score was 10, so we draw a line and put a hash there. And the minimum score was 0, so we draw a line all the way over here and put a hash there. So there is the box plot for the quiz scores. That's how we make a box plot. Now, of course, on your homework, you're welcome to use any sort of program you want to use to draw these things, right? I mean, you can print them out and hand them in if you want, or you can draw them by hand. It doesn't really matter, right? So that's fine with me. The homework, well, the in-class problem to start with is problem number 4. And then the homework is going to be 14, 16, 20, 23, and 24. Just 5 problems. And I'll have the book up here if you want to get a picture of it.